Hi, in this video we are going to discuss routes of chemical attack. It is a part of epidemiology and toxicology and it is under the new syllabus ID2 and old IB1 of Nebosh International Diploma. So our learning outcomes will be routes of entry, then physical forms and properties of chemical and defense response. So the routes and the methods of entry. So the hazardous chemical does not need to enter the body in order to have a health effect. For example, a corrosive such as concentrated hydrochloric acid will cause damage to the skin on contact. However, many hazardous substances have to gain entry into the body before they can have a health effect. The process by which the chemical gains entry and the route they take are important. So we are mostly concerned with the process of entry, how the substance gain entry into the body, and the route of entry, how it gets to the place where the entry is gained. So now we will discuss the process of entry. The processes by which the chemical gains entry and the route they take are important. To explain this, the epithelium covers the respiratory and the gastrointestinal tract in the same way as the skin covers and protects our outer surface of the body. So the space within the respiratory and the gastrointestinal tract is therefore external to the body, even though it is surrounded by the body structure. If I swallow a small piece of plastic, it may be inside my gastrointestinal tract, but it is not inside my body. It remains in the tube that passes through my body. So, the presence of toxic agents within the lungs or gut space does not, in this context, constitute entry into the body. It has to pass across the epithelium for this to occur. So, there are two main processes by which entry can occur: absorption across the body cover, either the outer skin, epidermis, or the lining epithelium of the inner tract, such as lung or stomach, or through the direct entry into the body structure where the cover is broken, that is via a break in the epidermis or epithelium. For example, cut or grazed skin or stomach ulcer where the stomach lining has been exposed and is bleeding. So in the picture we can see the respiratory epithelium. It is a thin outer covering as we can see in the picture. So now, what are the routes of entry? So the routes of entry can be through inhalation, then skin contact, or ingestion. The other routes could be aspiration, then mucous membrane of the eye. So now we are going to discuss inhalation. So inhalation into the lungs is the most frequent and significant route of entry for the majority of the hazardous substance. There are several reasons why the lungs are so vulnerable. The epithelium of the lungs has a massive surface area, and the lungs have a highly convoluted structure to create a very large surface area so that the sufficient oxygen can be absorbed from the inhaled air to supply the body. The epithelium in the alveoli, like we can see in the picture, is very thin and is in very close proximity to the blood supply. So it has to be it has to be to allow efficient diffusion of oxygen into the bloodstream. So this means that every other molecule that is soluble in the mucous lining of the epithelium can also diffuse across the bloodstream. So you have to breathe. It is not optional, unlike eating and drinking. Respiration demands that you inhale air almost constantly. Therefore, if chemical is in the air, it will be inhaled. So any inhaled substance capable of dissolving in the water or capable of passing through the membrane will also pass into the bloodstream. And of course, the lungs have a very rich blood supply. Once it is in the blood, the toxic substance will be efficiently transported to the all parts of the body, typically within 30 to 60 seconds of the inhaling toxic substance. It will be present in the blood in most part of the body. Consequently, inhalation is the primary route of entry that has to be tackled to eliminate or control the exposure of the majority of toxic chemicals. So now the next route of entry is the skin contact. So the skin is the second most vulnerable area after the lungs, as it can come into contact with solid liquid or gaseous toxic substance, possibly in a high concentration. The epidermis has many layers of protection and does not generally allow solid or gaseous substance to be absorbed. The skin is waterproof, so water soluble chemicals are unlikely to gain entry unless they remain in contact with the skin for a longer period of time. So the greatest risk comes from the chemical which can pass through the epidermis. This is called pervasion. The organic solvents such as benzene and toluene have this property. They achieve this by absorption, by dissolving the lipid membrane that the cell of the epidermis are made of. So if a chemical can pass through the skin in this manner, then contact with the liquid, gas or vapor will result in absorption. So the alternate process of entry through the skin is the injection. This is where the substance is either physically forced through the skin, example needle stick injury, compressed air injection, being cut with the contaminated sharp object, or through the introduction through the epidermis where it is damaged, like cuts, grazes, dermatitis, chaps. So now the next route of entry is ingestion. In the term of the occupational hazard from the toxins, the gastrointestinal tract is the least vulnerable part of the body. The possibility of the solid or liquid toxicants being ingested is limited. In most workplaces, people do not usually put toxic substance knowingly into their mouth. It can and does happen by accident. But when the ingestion occurs, the substance must be water soluble or able to pass through the membrane to be absorbed, and it must reach the part of the gastrointestinal tract where this absorption can occur. So, the stomach has a thick mucus lining to prevent the very acidic gastric juices attacking the stomach wall. So, a little absorption is likely to take place there. The absorption is most likely to occur in the small intestine where the food is absorbed. So, if I swallow a small lead pellet, I am unlikely to absorb very much lead into my bloodstream. So, the substance has to be water soluble or has to be able to pass through the membrane to be absorbed, especially in the gastrointestinal tract. And this is more vulnerable in the small intestine. The other routes of entry are aspiration. It is the direct entry of the liquid or solid into the lungs, which typically happens in two ways. When the substance that has been ingested are expelled in the vomit and run down in the respiratory tract, or when the substance are sucked directly into the lungs during pipetting or siphoning. This can be a very serious swallowing a hydrocarbon solvent is unpleasant but survivable. Inhaling can be lethal. Next is the mucous membrane of the eye. Substance may dissolve in moist covering of the eyes, and may be absorbed in the bloodstream of the eyelids and eye sockets. Next route of entry is through the ear. Though the ear canal is coated with ear wax and is relatively poor route of entry, it is possible for the substance to pass through the skin of the canal or the eardrum, especially organic solvent. So now we are going to discuss the next our learning outcome, that is physical forms and properties. The ability of the substance to gain entry in the body is hugely influenced by its physical form. This will determine the possible route of entry and may also influence the process of entry. So it can be solid, liquid, or gas. So now we will discuss about solids. So a solid can be in a massive form as it has a low hazard and can't be inhaled or absorbed by the skin. Solid can be in the form of dust and can be ingested or inhaled as it stays airborne for some time. Solids can be fibers. It is an elongated stringy matter and can be inhaled or ingested. And solids can be in the form of fumes. These are the small solid particles condensed from the vapor like hot metal, and it can be ingested or inhaled. Now the liquid can be in the massive form like acid stored in a bottle, and it can come in contact with skin or ingested. Or liquid can be in the form of the mist, that is fine liquid droplets suspended in the air and can be inhaled, ingested, or through the skin contact. The gases can be inhaled or can be come into or it can be through the skin contact, or the gases can be in the form of the vapor. The vapors are similar to the gases, but they are in equilibrium over the liquid form. So they can be inhaled or through the skin contact. So in the diagram, we can see the various routes of entry. So we can see that a liquid can enter the body through the skin contact, or the liquid in the form of the vapor can go to the lungs, or liquid can be in the form of the fumes. Solid can also be in the form of the fumes and can enter to the lungs, and the liquid can directly go to the gastrointestinal tract through ingestion. Solids can also go to the gastrointestinal tract through the ingestion. So this diagram is self-explanatory. Now the physical forms and the property. The next is inhalable and respirable dust. So the distinction between the inhalable and respirable dust is important because different occupational exposure limits are given for inhalable and respirable dust. The dust monitoring method used to determine the dust exposure are different depending on whether it is inhalable or respirable fraction that is being measured. So the inhalable dust, it is a fraction of the airborne dust that enters the nose and the mouth during breathing and is therefore available for deposition in the respiratory tract. The inhalable dust particles can be as large as 100 micron or more. So the inhalable dust is quite large particle, and they are mostly found in the nose and the mouth uh, tract during the breathing. The respirable dust, it is the fraction of the airborne dust that penetrates to the gas exchange region of the lungs. The respirable dust can enter into the lungs. And these are the dust particles that are larger than the 7 micron in the diameter and will have to be removed by the body's filtration mechanism. Only the particles less than 7 microns diameter will enter the region of the gas exchange. So respirable dust uh, can be either greater than the 7 micron or less than the 7 micron. If it is less than 7 micron, then it will be it can enter into the gas exchange region of the lungs. So our next topic is the defense response. So the body defense against the foreign agent are collectively called the immune system. The immune system is comprised of two complementary and interacting systems. The first type of immune system is the innate or non-specific immune response. This is the response by which a person is born with. It provides a rapid response, but it is not specific. There are various innate mechanisms such as specialized white blood cell like macrophages or the inflammation. The next type of immune system is the adaptive or acquired immune response. This response is targeted at the specific invader and takes time to develop. Once developed, a memory of the invader is formed and subsequent defense response will be triggered very quickly and is likely to be effective. The mechanism involves various types of specialized white blood cells. Now we are going to discuss the respiratory system defense. So we can summarize the deposition of the dust particle in the respiratory system as the defense mechanism at work in the respiratory system starting from the top are first is the nasal hairs. It filters out the larger particles greater than 10 microns. Then coughing and sneezing, which result in forceful ejection of the inhaled substance. Then trapping by the mucus secreted by the goblet cell lining the conducting waves. So the particles between 7 to 10 microns are trapped in the mucus, and the mucus traps the particles and are propelled towards the nose and the throat by mucociliary escalator, a mechanism, and forming a sputum, which is either swallowed or expectorated, that is spat out. Now the destruction by specialized attacking cell in the alveoli. So the smaller particles and aerosols between zero point 0.5 and 7 microns, as we saw before, that the size of the particles less than 7 micron enters into the gas exchange region. So the smaller particles and aerosols are between zero point 0.5 to 7 microns in size and passes into the respiratory units where they are deposited. They may then be ingested by the macrophages. Macrophages is the one form of the white blood cell, leukocytes, that are present in the body tissue. Macrophages destroys the foreign particle by phagocytosis. This is the method, and the cell ingests the foreign particle, secretes enzyme onto it, and then absorbs the digested remains. Now the next innate immune system is the inflammatory response. The lungs basically uh, filters out when the particles are in the solid form. But if it is in the vapor or the gaseous form, this cannot be removed. So, the filtration mechanism outlined earlier is not effective at removing the substance. This may be because the substance is not in the particle form, that is, it is either a vapor or a gas, or because the substance is inert and so cannot be digested by the macrophages. For example, silica dust. So, in this case, the inflammatory response may be triggered. So, inflammation is the means by which a white blood cell leukocytes are called to the site of infection or the injury. Typically, the response is the blood vessel dilates and the capillary walls become more permeable, and the protein rich fluid plasma exudes from the capillary into the surrounding tissues, causing swelling, or which is called edema. The leukocytes migrate through the capillary walls towards the harmful input, where they ingest it together with the damaged tissue. The tissue-dwelling macrophages joins with the other phagocytes and scavenge the affected area, which is sometimes additionally bonded by the fibrinogen, a protein associated with blood clotting. The fibroblast appears and secretes collagen. This fibrous protein forms the meshwork of the scar tissue, which steadily builds up to repair the affected area. So, to discuss it, uh, the inflammatory response is the innate response system which a person is born with, and uh, it when the substance is not in the particle form and which cannot be removed by the filtration mechanism, so then the inflammatory response gets triggered. So now we will see the acquired immunity. The acquired immune system is the primary defense against the viral and the bacterial attack. When a biological substance causing disease pathogen is detected, the part of the immune system produces antibodies in response to the chemical markers, antigens, or pathogens. These antibodies are used to attack the pathogen and destroy it, often by the labeling the pathogen so that other white blood cells recognize it as a target for destruction. While this system is critical in keeping the respiratory system free from the viral and bacterial infection, it can sometimes become triggered by the large molecule that in their own right do not represent a threat to the body, like floor dust. The floor dust are able to sanitize the respiratory system and evoke an immune response. This is known as asthma.